All right, so we continue our conversation. I have to ask, I suppose, how was the test? Sorry? All right, so we continue off our conversation, our discussion of so I think it was hard because we probably didn't study hard enough, right? I mean, I don't know. That's interesting. Which language? If you want, we can translate the questions. Excuse me, I'm serious. If you want, we can translate the questions so that you answer them in a language that you understand. Perhaps Nyanja or Chao. We can do that, right? Okay. You're free to go if you want to. So we continue our discussion, and today we transition into lecture number 3, which is we just want to have a short discussion of. Classification of computer systems, right? It's a fairly short discussion. But before we start, I just wanted to... mention that the Tuesday slot that you proposed, it's not going to work out, right? Sadly, you are late. So we set out for Friday, 7 to 8 hours in LRE. And this new slot, we're replacing this Friday session with, which session was this? Saturday, right? So instead of Saturdays, we shall be meeting on Fridays between 7 and 8 in LRE. But this recent change is effective next week. So we shall still meet day after tomorrow for our class, where I hope we continue our conversation of lecture series number 4, which is computer software. So we are meeting in Nelt, I think. I don't know if it's going to be open, but the day after tomorrow is. We meet Saturdays.
Oh, then the Friday one will start next week?
Yes.
Okay.
So the Moodle site is up and running now. I don't know, I think I've noticed, I'm impressed. Vast majority of you have actually accessed the site. We can see, right? Which is good. But we scheduled a training session. So if you think, you're uncertain about certain features of the Moodle, please show up at the library at 14 hours, right? There's an announcement that was sent out about that, so there'll be a training session between 14 and 16. We were told you're going to be split up into 2 sessions, right? So just show up at 14, and then if you don't want to attend the initial session at 14 hours, you can come later on. I'm not the one doing the training. The people that are in charge of the Moodle are the ones doing the training, right? You want to do this, right? And then I just wanted to mention also, there have been people sending emails trying to find out, are we going to have the quiz and whatnot? All these details were sent through via the mailing list. And also there's an announcement on the Moodle actually that was sent out a while back, right? About there being a test today. So, and usually what happens is if a class is cancelled, I again send out an announcement, right? Or I reach out to the class reps or something. So you want to make sure that you routinely check the announcements on the Moodle. And also, more importantly, because the vast majority of the announcements are sent through to the course mailing list, you want to make sure that you confirm that you're enrolled. And the thing is, the email that is associated with this mailing list, or the emails associated with this mailing list, are your UNZA assigned email addresses. I mentioned this, I think, in the previous session we had. It's student ID at student.unza.zm, right? And I think I have just a few slides to just showcase exactly how you access this if you are still struggling. I don't know if there's anybody who's managed to access their UNZA assigned email address. Anybody? Okay, that's good, one person. Right, so most of the communication, the reason I'm mentioning this, most of this communication is going to be done via the mailing list. And there's nothing like adding your personal email account there. It's just your UNZA assigned email accounts, right? Email addresses. Now, I normally wouldn't say this, but I know there's a lot of confusion going on right now. I don't know if people have spoken to you about this, lecture venues being locked and I had to confirm, right, if 2C was going to be open, and it turns out it's almost always open. So I think we're probably going to use the same venue on Saturday, right? But yeah, that's because your E is locked, and so the support staff have been advised by their union to down tools, so they've slowed down, right? They're on go slow, which is why they've locked most of the offices, right? We've not been taught to do anything ourselves, so which is why I came here, and I'm going to come on Saturday, right? I think. But what I wanted to say is just it's okay. I'm sure things are going to be fine eventually, right? So don't get discouraged because of the confusion that's going on right now. I don't know if this will make you sleep better at night today, but when I was a student myself, I was supposed to have graduated in 2006, but I graduated in 2007. I lost a year because when I came through, they shut down this place for almost 6 months, right? So I was delayed, but you know, life happens sometimes. It's fine. It won't be that bad for you. I don't think it'll be that bad. I'm just saying that it's okay. If you need help, like if you are confused about what's going on and you think maybe I might have answers, just reach out to me, email, or come and see me. Then we can chat about this, right? Things will be fine. Okay. And then so just a quick show and tell on how you access your email account, because it's really important, right? So it turns out that the UNZA assigned email addresses are associated with Google, right, or Gmail. So UNZA signed an MOU with Google, and so our emails are being hosted on Google servers or something, right? So what you do is you just go to the Google homepage, right? Make sure you're not logged on with your personal email account, and then you just click on sign in, right? Once you do that, what you do is and I'm using Alice's credentials here. Sorry, Alice. What you do is you specify your user ID is your student ID at student.uza.zm, right? Like so, yeah. So this is an example. Alice's email address is this, is a computer student ID or computer number, right? At student.unza.zm. And then the password is the computer number, right? So obviously, once you enter your email account, because it's the first time, you'll be prompted to enter the password, which is your computer number. And then once you log in, you'll be presented by this screen, just click accept, obviously. And then I think they've sort of like changed the configuration, right? The global configuration. And so you'll be immediately prompted to change the password, because by default, all newly created email accounts have the default password of student ID. So we want to force you to change that password, right? At least somebody gains access to your email account, like I did for this account. I mean, I was able to log in because I know that the default password is the student ID, right? So once you change the password, and by the way, Miss Alice Vula, your new password is, I changed it because I was prompted to change it, so it's now the same ID, right? So when you want to log in to access your account, Alice, this is your username and this is your password, but you want to change this because everybody in here knows this now. And then the usual stuff, you'll be asked to specify like recovery details, like a phone number or another alternative email address that you want to associate this account with, right? If you want, you can skip this by just clicking confirm. I suggest you click update and then change these details. And then, boom, this is what you'll be presented with. And this shows us a lot, right? Miss Alice has not been checking her mails, right? See when I started sending emails? February 17th, right? She hasn't read any of the emails, and I'm guessing the vast majority of people have not done this, right? You want to do this. So these are important information. Reminder about the quiz. Class has been cancelled. Confirmation about tomorrow's class. I was responding to Francis, I think. I don't know if it was Thelma. So you want to make sure that you check these details. And then the other thing, right? Now that you have access to this UNZA assigned email address, you can actually access the mailing list. Even though you'll be getting automated messages, by default, when somebody sends an email to ICT1110 at unza.zm, everybody who's a part of the mailing list, aka everybody in here, is going to receive that email, right? But if you want a fancy UI, you can go to this link, right? And then you'll be able to access the forum posts. An interesting thing about this is you actually have access to a historical record of all the different messages that were exchanged even last year and before last year. So if you're one of those people who's curious in finding out what sort of questions people were asking last year, I do highly encourage you to use this link and just read up on mails that were sent through last year, right? Right, is that fine? You want to go through these slides, they will be available, and then you can go through them and just follow them through, right? From slide number 4 all the way up to slide number if it's not clear, all the way up to slide number 12. Is that fine? Okay. Now that we're done with that, we start our discussion in this lecture series. So this is the outline really. Now the introduction, I promise you grow tired of this. It's the usual introduction. And then we'll look at we want to explicitly state the aspects that we're going to be discussing as we run through these different classifications of computer systems, or different types of computer systems that are out there. Yes? Oh, I didn't know that I slang I'm sorry that I slang a lot. We shall use the Queen's language from now on, I suppose. I don't know. I do not know, but okay. I don't know. I'll try and change. Sorry? No, I'm not too fast. Okay. Point noted. Thank you very much for the valuable feedback. So this is what we're going to do, right? All right, so like I said, I mean, you're going to probably grow tired of this definition of a computer system, but the thing needs to sink in, right? A reminder that our definition of this electronic computer system is, or a computer system is an electronic device that has the ability to accept input, process data, store the data, and eventually produce output, some sort of output. Because what you're interested in when you're using any type of computer system is for it to do some sort of processing for you. You feed it input, processes the input for you, it gives you back the output. Sometimes it stores the output, right? And we had a definition of what we mean by input, processing, storage, and output, right? So our broad categorization of these computer systems really is going to be in these 6 broad categories, right? Supercomputers, mainframes, server computers, mini computers, personal computers, or aka desktop computers or PCs, and embedded systems. Right, this is our focus, and this is important because when you go online and if you read some of these books, you notice that the categorization of computer systems is somewhat different, right? But really, we are interested in doing this because we are trying to set the stage for our next discussion, which is the so-called machine structure, the von Neumann architecture, right? It turns out that all these different broad categorizations that we have here, for the most part, conform to that same architecture, right? But before we start the discussion, we want to appreciate what these different categories are all about, right? And also to mention that as I'm running us through these different types of computer systems, our main focus is going to be based on the capabilities insofar as functionality is concerned, right? So are they general purpose? Are these specialized types of computer systems? Is it a sort of computer system that is able to do multiple things? You watch videos, you listen to music, you record, you actually turn it into some sort of, your room is a recording studio, but you use your computer, right? It's general purpose. You browse the internet, you watch movies, whatever, right? So whether it's specialized or if it's general purpose, and the relative size of the hardware component, right? In terms of the form factor, how does an embedded system, I suppose, compare with microcomputer, right? In terms of size, right? So relative size. And then our categorization is also going to look at the efficiency, right? So how fast is this computer able to process data for you? And then finally, I guess it's a big one also, the relative cost of the machine. It turns out that this computer system is much cheaper, or is slightly cheaper than something like this, right? Supercomputer is far more expensive than a PC, right? So those are the things we're going to look at. So you notice these things come up. And again, similar to our discussion of the history of computing, you notice some of these aspects actually are tied to what we discussed last time. We looked at the 5 generations of computer systems. Stuff that came into the quiz today, right? So you notice that some of these things will come up again, right? So pay attention. The behavior or the pattern will be somewhat similar in certain instances, like when you look at power consumption, things like relative cost. You notice as you go high, and it turns out that this is the opposite, right? But as you traverse through from the smallest all the way up to the largest, the cost somewhat increases. the efficiency increases, the size increases, right? Although there's a thin line between some of these aspects, like once you notice, once we start our discussion of server computers, it turns out that I can actually turn this thing into a server, right? You know, so there's that blurred line between some of these types of computer systems, but we'll mention a thing or two about that just now. So I hope this makes sense. And also, I wanted to mention that, again, we are restricting our discussion to this, right? So you again find, as you are reviewing existing literature, that some categorization is based on the different process architectures, right? So which particular model is this computer based on, right? Is it based on the von Neumann architecture, for instance, or the Harvard architecture? We're not interested in that for our discussion, right? The reason we are categorizing these things is because at some point we start discussing the von Neumann architecture, right? Again, when you read up, you notice that the categorization is also clustered based on how instructions are actually processed. We're not interested in that, at least not at this point in time. When we start our discussion of computer architecture, we'll probably revisit some of these things, right? So just wanted to put it out there, right? We're restricting our conversation around these classes here. Right, so start with the smallest going high up here, right? Just like we start with the simplest quiz until the most complex quiz. All right, so really the so-called embedded systems or embedded computer systems comes with so many different names, right? The relatively small-sized devices that are integrated with relatively smaller computer, right, or a microprocessor. So an embedded system is not in its own right a computer per se. It might not be, right? But it may have a processor inside the computer itself, which is why it's called an embedded system. The computer is embedded within the device. So this thing here has an embedded computer system within it, right? But it does much more than that, right? I forgot to bring the Zesco customer interface unit, but it's a classic example of an embedded system, right? The microprocessor is embedded within it, but this thing is not a computer in its own right? And I guess also when you start looking at these more obscure and I guess they become mainstream topics like robotics, for instance, that could be classified as an embedded system because it has a processor inside it, right? But the device itself does something much more, right, than what your average computer does. Right, so like I said, some key traits here is you have a built-in processor that's embedded within it. And it might be the case sometimes that there's no direct interface like a keyboard and a mouse, right? Sometimes, well, the interface could be as simplistic as this customer interface unit where you just have this number pad, that's all. Right, just punch in numbers and then depending on the sequence of numbers, your input is going to be processed by the computer system. If the input doesn't make sense, then obviously you'll get an error or something, right? Certain embedded devices, like I think this is an Arduino, if I'm not mistaken, there's no interface, completely no interface. So for you to actually work with this thing, you'd have to start integrating it with peripherals, right? So it has ports that can be used to integrate it with things like keyboards and the mouse and an LCD screen. And in most instances, you typically have relatively small computer programs that sit in read-only memory, right, in ROM. So unlike a computer, which you can easily wipe, you replace the computer system, you install new software, you uninstall software, it's usually the case that you're unable to do that for certain embedded systems like this, right? All right, and also, key thing here is that they typically perform dedicated tasks. This is not general purpose, right? It's perform one function, a single function device. So what it does is maybe dual function, I suppose. It flies around and then it allows you to, it also takes like aerial images as it's flying, right? As you are flying it, actually. Right, so as specialized functionality, right? So it's the dedicated task that it performs. And obviously, your microcomputer just performs the same dedicated tasks, right? So these digital cameras that you're buying, this could be viewed as being embedded systems, right? The more modern ones, actually. When you start your discussion of computer networking in EDU 1020, you have a discussion of these network devices called routers and hubs, right? Those are embedded systems or examples of embedded systems, like drones as well. I mean, we can go on and talk about these usage scenarios. It's become common nowadays for people to barricade themselves in gates where, as you are going out, you press a key and then it opens, right? And then you press the same key, it closes. Single function device, right? So the thing is embedded. Typically, I don't know if you've seen this in gates, right? At entrances, you have like that embedded system sitting somewhere there, and that's the one you interact with as you are pressing that so-called remote key, right? One button only, press the button open, press the button close. Single function device, right? I wonder if people have ideas of other embedded systems here. Is this an embedded system? Oh, okay. I don't know. I didn't know. Okay, so apparently this is an embedded system also, right? Is it? What other examples can we think of? No. The key for the vehicle, no.
Oh, the vehicle also has like a kind of remote.
Yeah, but you notice when I know what you're talking about. You see, what she's saying is, you know how most vehicles now, you press the key, the door opens, right? Yes. Automatic locking system, right? That's what she's talking about. That's not embedded. When I was giving an example of these gates, right? I made reference to that embedded system, that the component that sits somewhere close to the gate, at the entrance. The key that you have, the thing you press is just an input device. It's a peripheral. It's like this, right? So I guess maybe the argument would be like, maybe the key has, don't think the key has a microprocessor. No. Maybe it does. For certain fancy vehicles, I don't know. This would be interesting. Homework, let's find out if a key is an embedded system. I don't know. Sorry? Yeah, it's an interesting exercise, right? And I encourage you to, your thinking should somewhat change slightly as you're moving around and you see certain weird things happening, right? Ask yourself, I mean, how does this thing work? Like those lights that when you're walking around, I think they switch on, I don't know, right? Someone is saying yes. What is that? Is that even?
Those ones that have badges and just put on the wall and the door.
Right. Well, it is, obviously. The modern ones, right? Yeah, remote controls also. I think they're more modern ones. But this is, we are following here, yes?
I have a question.
Oh, I thought it was, yes.
Yes, I have a question. You say that the thing you're coding is an embedded system.
I don't know, I didn't say that. Don't quote me on that, and I have proof that I didn't say that.
I wanted to ask.
Okay.
Yes. If you gave an example of the gate. When you're opening the gate, you have something similar to that.
Yeah.
And what you're holding is not an embedded system, but what the box that is seated by the gate, that's the embedded system.
Yes. Well, for me, right, and I thought I had an example here.
So meaning what you're holding is the referral, and then that thing on the ground is...
In certain instances, that's an interesting question. In certain instances, the peripheral itself might be a computer system, actually. Think about this for a second. As far as this computer is concerned, this is a peripheral, right? It's an output device, is it? Right? As far as this computer is concerned, this is a peripheral. It's an input device, you know. So it's a sophisticated input device to a certain extent here because it's not like if I was using the retarded type of pointer which doesn't allow me, there are certain pointers that you just press it once, you see a red LED light emitting down, right? That's how it does, but this thing does much more. So there's a microprocessor inside here. For this, yes. So what I'm trying to say is the question you're asking about the remote for the gate, I don't know because you'd have to check if the thing actually does, we'll have to look up if the thing actually does have a microprocessor. The key thing is just think about these embedded systems from the perspective of the core functionality of the functional units of the computer system. Input, output, CPU, right, for processing, and storage option. Do you understand this? Is this thing an embedded system? You should look up, just Google up, is a modern day optical mouse an embedded system? Turns out it is. If you were to rip this thing apart, you find a microchip in here. Right, but you had a comment there.
headsets like these?
Yeah, I don't spend a lot of money on headsets. The Beats by Dre, maybe there, I don't know. I don't know. I know what you're asking. Say fancy headsets, are they? Maybe, maybe not. I don't know. The wireless ones, maybe.
Yes.
Probably. That's probably the case, actually. Right. So you should always, in all these different classifications that we're talking about, think of these things from a perspective of this: input, processing, storage, and then output, right? Or input, the I/O module, the CPU, central processing unit, the memory unit for storage, and then the output module, right? If whatever component you're thinking about or you've come across has all these different aspects, then it's a computer system, right? Hopefully that makes sense. All right, there are obvious advantages here, right? In terms of portability, usually because this thing is embedded, so it's the computer itself that's embedded within the device is obviously portable, right? This is very, very advantageous because this is why you can easily embed it into an existing device, right? You buy a microprocessor somewhere out there, you develop, hopefully you invent some hardware component or some embedded system that does fancy things, and then boom, right? You're able to do that because it's portable. It's also very cost effective, right? This can be mass produced because they are small, right? Compare that with a computer system such as this. And obviously, to a certain extent, they're efficient because they're efficient to a certain extent, for the most part, because they're single function devices. This thing is, like right now, if you were to view the things that are running on this computer, right, if I just view these are all these different things I just came out here. These are the different processes that are running on my machine, right? A ton of them. So behind the scenes, there are background processes that are running, right? Because it does so many different things. The operating system is running. I have multiple applications open here. There are certain applications that I can't even see, but I know they're running, right? There's probably servers, web servers that are running here as well, right? So, but because this component here, this computer system here typically performs dedicated tasks, to a certain extent it's efficient. It only does one thing, or maybe two things, right? And also minimal power consumption, right? Which is why all this thing needs is 2 AA batteries, that's all, right? Actually, 2 AA batteries, although it uses PLC, a protocol called PLC, so power line communication, look that up. So this thing a friend of mine was confused one time, right? So he comes to my place and he's like, but how does this work, right? And I was telling him to say, if you haven't connected this thing if you haven't connected it to a main supply, it won't do much, right? Because it uses the same power line as a communication channel or a communication system, right? So anyway, bottom line here is minimal power consumption, right? Some drawbacks for so-called embedded systems. The obvious one, single function device. Who still puts on wristwatch here? Why would you put on a single function device, right? but the thing is you have little control over that. It's a single function device for the most part. You can't do anything other than just provide it with input, right? For this thing, if I decide to say I've changed my mind, my career path has changed, I want to become a musician, I want to start recording music, I can just start installing software for doing that, right? For making beats or something, whatever it is people do, right? Synthesizing, I don't know, synthesizing beats, I don't know. But the disadvantage here is you have little control because typically these things perform dedicated tasks, and the software, the software program or the application that runs this embedded system is typically sits in ROM, right? So you can't change, it's difficult to change. Sometimes you can change it, but in certain instances it's very difficult to change. So single function device, I guess this comment here is there because it depends on the device itself. So let's just say to a certain extent they're not that reliable, right? But in certain instances they are reliable. I know this thing is reliable, right? A classic example, I was going to say, I wonder if the BIOS could be considered. No, it's not. Okay, fine. So advantages and disadvantages, right? And then comes so-called microcomputers, right? The likes of your mobile device, not the feature phone, but the smartphone and something like this. Your feature phone would be a classic example of an embedded computer system. Why? Dedicated tasks, right? Well, sure, maybe you play games, but you can hardly change the things that are there, right? Have you ever installed those cheap phones, the feature phones? Are you able to install software there yourself? No. Right? So you could just call SMS, maybe just play games that were probably placed into ROM or something, right? Although, I mean, these days and this is interesting here. Have you ever experienced a situation where you've heard of an OTA or something where your mobile service provider will send you certain configurations, so it doesn't matter if it's a smartphone or a feature phone, you still get those things? Do not be deceived, they're not going to your phone, they're going on your SIM. So here's a question here, food for thought. Do you think that that SIM would be considered an embedded system? Not the phone, right, the SIM?
Yes.
Okay, I don't know, right? So it's saying yes. So this is interesting. These are things you want to think about, right? And don't be deceived. Yes, I know maybe people are thinking, no, but my mobile service provider sometimes will install software on my phone. No, they're installing those things as part of what they call, is it a SIM toolkit or something, right? So it's going on the SIM, not your phone. When you open up your phone, the SIM card probably has a microprocessor there, right? But anyway. All right, so microcomputers also, or aka PCs or personal computers. These are probably the most common types of computers, right? Reason being obvious because they're general purpose, right? You can do so many different things with them. Vast majority of us probably have smartphones in here. We use these smartphones for different things. For some people, I know for my mother, it's just a smartphone, but it's just WhatsApp. In fact, she says spam now, right? I don't know how to, I digress here. But for her, the phone is mostly WhatsApp and calling. For me, Instagram, Strava when I'm cycling, email, right, on the go, it's a general purpose thing, right? But take our point here, because it's general purpose, different people use it for different things, and that's a real power of a PC or a personal computer, right? I use this thing for completely different reasons that you do. I've bumped into students who, I bought a computer and all they do is just the browser. At least in first year, just the browser, email, right? And playing music and watching videos. That's fine. You can do that because it's general purpose, right? The secretary uses it for a different thing. Your lecturer uses it for a different thing. Mom and dad use it for a different thing, right? General purpose. And then typically these things provide more interactivity to the user. Why? Because the general purpose, you can easily integrate different types of peripheral devices. I would be surprised if we have people that are addicted to gaming in here, right? You probably have some control or something that you hook up to your hopefully your computer, right? Your PC, you turn your computer into a PC gaming machine, right? Because it's general purpose. And you're able to do that because it provides more interactivity. If you want, and I'm sure there are people that have done this, you can hook up like fancy peripherals and start interacting with it just like you would a PlayStation or something, right? Like what do they call that thing that accepts gestures as input? Xbox what? Is it yes, okay. I've lost track with gaming here, but so I apologize. Okay, so yeah. So some characteristics here, like you already know this, right? And I decided to beam up a different type of personal computer, but I'll be making reference to different types, right? Something like this, like a desktop computer like this, is a PC, right? Or a microcomputer. So perform general purpose tasks, and then it's obviously widely used, right? I was going to say at some point it was probably the most widely used type of computer system, but not anymore. These days it's embedded systems. I think with the advent of IoT, the Internet of Things, I don't know if people have heard about this. If not, you shall have a discussion in ED 1020 about this. People are connecting crazy things to the internet now, right? Your fridge can be connected to the internet. You can buy, like if you're a fitness freak, you buy those bands, right, that continuously sync to somewhere in the cloud or something, right? That's an embedded device, right? Maybe you're a pet lover, your dog probably is microchipped or something, right? So the Internet of Things, and in fact, again, when you start your discussion of computer networking in ED 1020, you understand why IPv4 was gradually being replaced by IPv6, because the number of IP addresses are running out, right? Typically, when you're hooking up to the internet, a device is allocated a unique ID, which is an IP address, right? But because more and more things are being added or connected to the internet, those things are eventually going to run out. And so, solution, provide a different addressing scheme, right? There's probably more embedded systems than there are microcomputers. That's what I'm trying to say here. Think about this for a second, right? So many different, so many different, this is boring, again, so, I'm trying to make this more, I don't know if this is the right time to say this again. Let me pause for a little while here. But let's not misrepresent what's going on here, right? This is not like punishment to write tests and whatnot. It's about learning. It's about learning, and I don't want you to lose focus of that. No, this is serious. This is about learning. It's about you understanding this. And some of these things will come back, by the way. Some of these things will come back once you leave this place. Some of these things will come back in second year. Some of these things will come back in third year, fourth year, right? So this whole thing is about learning. And in fact, if it were up to me, maybe the assessments would be somewhat different, right? I've been in schools elsewhere where you're given take-home exams, right? So you have enough time to actually work through the problem, right? That's besides the point. Yes? There was a question.
Yes. I explain more on how you can connect a fridge to the internet.
What?
I want to know. Because I don't know. I've never heard of
Well, so I've not done this before. I'm trying to think of maybe a. Let me use another example, because I wouldn't want to start lying about a refrigerator. Let me use because I don't know how that would work. There's more actually besides the refrigerator actually, but let me show you. I hope I have that thing here. Let me use an example that I'm familiar with. Hi. Okay, that's fine. Oh, you didn't have to. This is synonymous to. No, it wasn't. I think she felt bad, right? She thought I was. No. It was like, may I leave the room or something? Let me use this as an example, because I understand, even though I didn't do this, but I understand. I was reading this really interesting work, and I think this. Oh, I didn't know there was this architectural diagram. This is perfect. I attended a very nice presentation. It's a postgraduate student who was working towards. He implemented some sort of platform that is aimed at automatically notifying people to say there's an armyworm infestation. I think I gave an example. I rented about armyworms in lecture number 1 or 2 or something. This was actually because I just read about this, right? So I thought I would include it as an example. So an example of how we can view this as a refrigerator. You see this trap here, right? This is called a trap. This is a thing that captures the armyworms or the insects, the different insects. So this device itself And actually, it connects to the internet using GPRS, I think. So they put a SIM card in there. The SIM card is what connects this particular thing to the internet, right? So this would be like your fridge, right? So there's a SIM card in there that enables it to be connected to the internet. And then routinely what it does is it synchronizes with some application that is somewhere on the cloud. And we'll talk about cloud computing just now, right? Somewhere on the cloud. So this is how the connection would be. And I imagine the refrigerator would be the same. I was a bit hesitant because I doubt if you'd need to slot in a SIM card in a smart refrigerator if there's such a thing, right? But maybe it would be connected to some sort of local area network that you have at home, right? Just like the people that run a lot, that I've never used those things, the fitness band, I don't know what they call it, but I'm guessing that thing probably connects to your phone, right? So it gains access to the internet via your phone. But the moment it does that, it needs to be uniquely identified somehow. So it needs its own IP address, right? It's immediately connected to the internet. Just like the moment you connect your phone to the internet and say, I have bundles now, the moment you do that, your phone has access to the internet. Everybody else has implicitly access to your phone, right? Although it's not as simplistic as that, actually, because it turns out that your mobile service provider makes use of what they call internal IP addresses. So technically speaking, only people that are on the same network as you, which should be a wide area network, would have access to your phone, not somebody who is connected to a different network. So if I knew the IP address of your phone once you connect to the internet, and you're on Zambia and I'm on MTN, I couldn't directly communicate with you using your IP address because I wouldn't be able to see it. It's private, right? So this is how, anyway, this is how it will be connected. Guys, we are living in exciting times. So many fancy things going on. Perhaps some of you work on a capstone project that involves, or that will involve working with these IoT devices. It's become the in thing now. People are doing all sorts of fancy things with these, right? Think about this for a second. If Zambia decided to say, and I had a class with a data mining class, and I was telling him, say, elsewhere in the world, right, these so-called, I don't know if I mentioned the toll booths example. Did I mention it last time? You see those toll booths where you pass through? Elsewhere in the world, you don't need a human being to sit there and say, give me money, and then they press a button to open. Elsewhere in the world, all that, the process is automated, right? But think about this for a second. How is it going to be automated? It has to be hooked up somewhere to, like somewhere, right? Some computer network somewhere. For you to hook up to that particular thing to the computer network somewhere out there, or to the internet, obviously it needs to be connected. Right, so the moment your vehicle comes through and you put in money or something, or not money, because if it's a remote toll gate, you don't want to put in money, you are swiping maybe, right? Or you have a card that has money pre-allocated there. The moment you swipe your card or whatever, if it uses RFID, the moment you just hover over the place where you need to swipe it, boom, the thing just opens, right? But there's a number of things happening there, right? Your account needs to be debited, right? Because you've made a payment. And then they have to check that you have enough money, they have to deduct the money, and then they open the gate, right? Without human intervention, right? So all that is possible because all those remote devices that you're using would have to be connected to some network, right? It doesn't have to be the internet, but to some network out there, although the internet is a network, right? Is this making sense? So exciting things, guys. We are living in really exciting times. I don't think there's any exciting time other than now. But I know 50 years from now, people will be saying, what were those people doing, right? All right, I don't know what we're talking about here, but anyway. Right, so some typical examples of so-called personal computers or microcomputers here. This by no means exhaustive here. So so-called desktops, those things that you purchase, yes? Oh, sorry, yes.
For computer system like that, where you just swipe, it means it has a specific instruction. That makes it an embedded system, right?
What?
Specific.
A program, yeah. There'll be a program there. There'll be a program sitting in the device that you're interacting with. So the device you're interacting with is the device that's integrated with the provision that you have where you swipe your card or something. I don't know if I'm answering your question.
No.
It would be working similar to the way when you go into shop right there these days, you don't pay cash now, is it? Move your card, you swipe that device, so I guess you could call it a point, what do they call that? It's not a point of sale machine. The payment system, we can call it the payment system anyway. The payment system would work in the same way as you would if you had to swipe and go through a toll gate.
So, is it embedded or not?
It is embedded, that would be embedded. But again, it would depend actually. In certain instances it would be embedded, in certain instances it wouldn't. Like an example that's close to home is an ATM machine. You know that if you have to rip it up, there's a machine, in certain instances there's a computer just like this actually, right? So it depends. But for something that's remote like that, I imagine it would be an embedded system. Why? Because putting something like this would be costly. You have characters that will just go and vandalize and steal that thing if they know that it's an expensive thing, right? Unless if you have to fortify it like they do the, I thought this was funny. I was cycling home this one time last year, and I bumped into this guy. He was moving the speed trap. I didn't know they moved them around, right? He was actually removing it. And so I stopped, right? And I'm telling, what are you doing? And he tells me, well, his vehicle's branded. So he tells me it needs to be moved somewhere. So they try to catch unsuspecting victims, right? So we need to move it somewhere. Once people discover that it's here, it has to be moved somewhere. So they move it around. But it has an expensive embedded system. Well, the expensive part is the camera itself, right? Not the embedded computer system. So I guess it depends on whether or not that would be an embedded system would probably depend. It's dependent on the usage scenario. It might not be. I don't know. All right, so some examples, desktop computer. Oh, and I bought a desktop, right? My first desktop was, I don't know if this is, I got the same, I think I might have gotten this screenshot because it was a memento, so it reminded me of the past. My first desktop was a Dell Optiplex, right? So anyway, so an example is a desktop computer, laptops, handheld devices, tablets, smartphones, right? All those are examples of PCs or microcomputers. I would like us to wrap up on some obvious advantages of these things, right? We've already mentioned the fact that they're general purpose. This is a big one. This is one of the reasons why the average human being now has, not the average human being, not the average. I think there's still a lot of people that don't have access to smartphones, right? But increasingly more and more people are gaining access to microcomputers, aka things like smartphones. Why? Because the general purpose is a big one. They're also cost effective, right? So it's affordable. You can actually get a reasonably spec'd smartphone now for less than 500 kwacha, right? Although maybe you'd probably have to start thinking about buying a new one 6 months down the line or something, right? You're better off investing slightly more. I was talking to a friend of mine when I bumped into him, a very good friend of mine. He tells me he's obsessed with phones. Oh, you still have the same phone? I've had this phone for 4 years now. I'm like, yes, I do. I mean, it might seem like it's because it's affordable. Right? In the long run, it's actually affordable. You understand what I mean? Generally portable, fits in your pocket, right? You don't have to strap 2.6 kilos on your back, right? If you're not strong enough, like my father, you'd probably struggle with this, right? Do you understand what I mean? So, but to a certain extent, it's portable. I guess the obvious disadvantage is related to some of the discussions that we're going to have with these other different types of computer systems, right? So to a certain extent, and again, there's a thin line when we're talking about limitation in processing power. There are certain servers, right? I'll give you an example of the server in the Odell laboratory, right? It has 32 GB of RAM. So that 32 GB of RAM is shared amongst the 50 terminals, those dumb terminals that are there. They're dumb terminals there. So you don't, the labs in the computers in the Odell laboratory don't have the dedicated desktop machines, right? So they all connect to the server. They're just dumb terminals. They all share 32 GB of RAM. Think about this for a second, right? This laptop here has 12 GB of RAM, right? So what I'm trying to say is, even though we're saying one of the limitations for these microcomputers is limited processing power, it's not always the case, but for the most part, right? They have a certain limitation. If you wanted to do something more complex, you probably need to gain access to server infrastructure or a supercomputer or something. I was hoping we could wrap it up on microcomputers, guys. I think you need time to go and brood about the quiz. And also, I'll see you on Saturday at 9. Can I ask that, you see, we meet at 9 on Saturday. We'll meet at Nelt. If not, Francis can quickly come up to well, I'll probably come down anyway. I'll be in my office, but I'll come down. If not, we'll find another venue and then continue our discussion. We shall continue until they tell us to stop. Unless there are any questions, unless there are any questions, I guess we'll call it a day. Yes, if there are questions. Probably next week. By next week, you should have them. Yeah. But the thing is, usually, right? If you are following through with what I was saying before, you actually have access to the results by the weekend, but using Moodle, right? But I'll send an announcement once the marking is finalized. Yes. No. So usually what happens is a couple of things happen. The discussion of the answers is meant for the tutorial session so that you understand why the model solutions are the way they are. It's not done in class. But also what is usually done is the model solutions are also shared with you on the Moodle, right? So you have access to those things. So that when you have your discussion with the tutor, you're already informed of what the solution was about. Yes?
When are we concluding our session?
Like I said, I don't have control over that, but I'll do another follow-up with my HOD. But with this confusion going on, I don't know actually. Don't know. But we can continue and accelerate because the things we're covering now are much easier, right? So this is like you can do this on your own. Do you need a tutor to tell you the history of computers? Yes. Oh, okay. It's worrying, right? Are there any questions? No? Yes. Sorry? The hell of a function is like it's like a module, a component of a computer system. I mentioned this in the class. I know what you're doing. Excuse me. This is good. These are interesting conversations, right? I know what you're doing, but I know what you're doing here. So, listen. Let's. I know what you're doing. You're trying to be petty here. Even if you did not know what a functional unit is, really, there's this sentence that tells you to say functional units. These are the input. Come on. Even if you didn't know what the definition was, you'd know that I'm talking about these things. I even underlined them. So functional units are just subcomponents. In this case, the subcomponents of a computer system. High-level subcomponents. No, you're right. Okay, if there are no questions. Oh, also, what normally happens, right? The reason I was telling you about that mailing list, if there are more questions, like some of you have already started, you send an email, preferably to the mailing list so that everybody sees it. And this time around, I just wanted to tell you that I will not respond to emails coming in from your personal accounts. You must use your own assigned email. So what I'll do if I were you over the weekend is I'll just go through the slides and familiarize myself with how to use or how to access your own assigned email. Just go through these slides here, and then start asking these questions you're asking. Yes.
I just wanted to know on the marking of the questions.
Yes.
If let's say you failed all the functional units, but you know for certain to say you passed all the generations, how are you going to mark?
So the question, I don't know why I'm discussing this here, right? The split of this is such that each one of these functional units have a mark. 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, so that the total is 5. So if you get half, right? But please, the marking scheme will have details of how the grading is going to be done. So it's a transparent process, really. There's a question? No? Okay. No, mega please. Okay, guys, we are wasting time here. Sorry. These things are going to be available online. See you on Saturday, right? Hi.